Okay, recording has started. So now, at this point, we know how to provision EC2 instances, a fleet of EC2 instances. We did it. We talked about AMI, Amazon Machine Image, and from AMI, how we can kick off EC2 instance so easily. We talked about that. And we're also familiar with region and availability zones, right? So now let's talk about the load balancing. So load balancing will provide a central front door to your EC2 instances. It's not specific to EC2 instances, this concept, but in this case, we started with EC2. So let's say we have a fleet of EC2 instances. We have 10 web servers to serve the traffic. In fact, you may be wondering, why do we need 10 EC2 instances or 10 web servers, right? Why can't we serve with one? Well, you have a scaling issues. So let's say you have one Apache server or Tomcat server, and you found out that it can handle 20 concurrent requests. And then when 21st concurrent request come in, at the same time, your Apache is not able to handle it. Your EC2, your server is not able to handle it. That's what you found out from your load test. Typically, from load testing perspective, when you do your load testing, you will know what your capacity is. You do the capacity testing, load testing, performance testing, and you will have your performance metrics. So let's say your objective is to respond to your HTTP request within 2 seconds. So you will keep watching it. So you will keep pumping the load to that EC2 instance and then say, at what point will it cross my threshold? Okay, after 20 requests per second. As soon as 21st guy come in, my performance degradation started. Okay, that's the limit. So you kind of extrapolate that. Let's say you need to scale. Your web application should serve about 2,000 concurrent requests. So 2,000 divided by 20. So you need 100 EC2 instances. That's how you calculate. That's how you'll find out that how many EC2 instances do I need. So you need 100. So that's the scalability. And now there is another aspect of architecture called availability. So when we talk about availability, so I want my web application to be up all the time. Well, when you say all the time, 100% of the time is not possible because you'll have to do a continuous upgrades and you'll have to do a code deployments and all. So 100% may be not practical, but at least say that, let's say 99.9%. Amazon says that. I'm sure what happens if Amazon.com is down? Pretty much the whole United States, not just United States, pretty much, all over the globe, they sell the goods, right? So they can't afford. They can't afford to have these, big deployments and all. Anyway, that's the concept of availability. Let's say Amazon.com is running on a Tomcat, just for discussion's sake. It's a Java-based web application running on Tomcat, and they found out from their load testing that they need 100 EC2 instances, and they're running from Ohio region, just for the discussion's sake, yeah. And we have 3 availability zones in Ohio. So they said they need 100 EC2 instances, Tomcat, and they divided. Let's say, let's start with let's start with the simplistic scenario. And the worst case scenario is they put all their eggs into one availability zone, one data center. So 2A. So they deployed all of their EC2 instances in 2A. What happens? If God forbids something happens to that, that availability zone, the data center, that city, then your website is down. Forget about your 99% SLA, you're back to zero. So you want to distribute your EC2 instances across all the availability zones. It's very critical, because even if one availability zone is down for whatever the reason, then your site is not down. So if you know that you need at least 100 EC2 instances at all time, then you will have to architect it that way. Make sure that they're distributed across all these availability zones. Probably you want to do a 40, 40, 40 across 3 availability zones. Then what happens if one is down? Then you have 80. So that's not enough. How about 45, 45, 45? Maybe if one is down, then you have 90 EC2 instances. So you have to play that number game. As an architect, you have to think about it. So even in the exam, you'll get questions like this. So you need 100 EC2 instances at all time. And then you need to be able to survive the loss of one availability zone. Meaning, even if you have one availability zone is down for whatever the reason, your website should be up and running in a normal capacity. So that means you need 100 from 2 availability zones in the worst case. So that means you need 50. So that means you will have to deploy 50 EC2 instances in availability zone 1, another 50 in 2, another 50 in 3. So even if one is down, you have 100. You need 100. But in normal circumstances, when all 3 are there, then you have 150 instances. I know you are paying little extra. I know you have additional EC2 instances, but that's how they cover, because architecturally, your non-functional requirement says that even if one availability zone is down, your website should be up and running, should be healthy. So being an architect, you have to think through that. Distribute your EC2 instances across all the availability zones. So that's why the term availability come into picture. So when we talk about availability in the industry standard terms, when we say 99.8%, I think your site could be down 8 minutes a month. You can Google it. So if you say that my site should be 99 availability in minutes. So you have, if you say 99.8% availability, if you claim that, if you want to put it somewhere in your SLA, then you can have 87 minutes downtime. And if you claim that you have you want to have a 99.9% of the availability, that means you have 40 minutes downtime. Make sense? Then if you really claim that 99.99%, then you have 4 minutes downtime per month. That's it. You do 1,000 deploys, but you cannot be down for more than 4 minutes in the entire month. If you boldly put it in SLA, your service level agreements, and if you go below that, then you will get sued. In my previous life, we wrote contract, being a vendor, we wrote contracts with the clients. We have a 99.98% of availability. So we had about 8 minutes per month. So within 8 minutes, you'll have to finish your deployment. Even if you have any deployments, even if something is down, you will have to fix it in 8 minutes. In fact, we did not fix it. We cannot fix it within that 8 minutes. So that's why you have to maintain this active standby environments. That's one of the architectural strategy, to maintain that active standby. If something goes wrong active, then just switch over to standby and then leave there, and then identify what the problem is later, what the root cause is later. So that's the availability part of it. So you have to, being an architect, you have to understand the scalability, availability, and other things, security, durability, and other things. But in this context, those are two things. Understand that. So coming back to the load balancing, let's say I have 3 EC2 instances in availability zone A, and I have another 3 EC2 instances in availability zone B. I want my clients, I do not want to expose these individual IP addresses to the clients, because what if one of them is down? I want all of them to go through the front door. That front door is called the load balancer. That front door, so you'll be able to share only the IP address of the load balancer or the DNS name of the load balancer to my end customers. The customers don't know. They will go to the front door, and front door will decide how many EC2 instances are available and what request will go to. First request will go to the instance, EC2 instance 1. Second request will go to the second guy, third one here, and then fourth one in a round robin fashion. You can do it, or you can define your own algorithm. In addition to that, load balancer will do the health checks of these EC2 instances, meaning behind the scenes, it will continuously pinging, or it will check the heartbeat of these EC2 instances and say, are you healthy? Are you healthy? You can define those health check thresholds. How often do you want to check it? So if there should be some mechanism to find out the health of these EC2 instances. It may not be that if EC2 instance is up and running, it doesn't mean that your application is up and running. Maybe your Apache is down. Your EC2 instance is happily running. It's not in stop state. It's in start state, beautiful running. But Apache inside that having issues, and Apache is down. Then I do not want to send that request to that EC2 instance. Load balancer will take the request. Load balancer has a concept called a listener within that. So that listener will be exposed to these end customers. The end customers, so it will be listening on a particular port. Let's say it's a HTTP load balancer. You're talking about HTTP traffic, right? Your web traffic. Then this guy will be listening on port 80 or port 443. 80 is for HTTP, 443 is HTTPS. HTTPS is better, but for our purpose here, we will be using port 80. So load balancer will be listening on port 80. It takes requests on port 80 from all these guys. And then it will send it to we call it target group. Okay, so the group of EC2 instances, they call it target group. So the target group will have a fleet of EC2 instances, and it will continuously check the health of each EC2 instance. And you have to find out what is your definition of healthy. When you say this instance is healthy, what exactly do you mean by that? You have to define your own health check. Maybe in your Tomcat based dynamic websites, maybe you define your /health endpoint, right? And that response, that response by checking with the database connection and several other things, whatever it needs to do it, and then respond back HTTP status code 200. If it is 200, then load balancer thinks that, okay, I'm good. This EC2 instance is healthy. If it fails 2 consecutive times, then You can define it. If it fails 2 consecutive times, then mark that EC2 instance as unhealthy. This cross mark is that. Once load balancer defines or load balancer decides that through health checks that an EC2 instance is unhealthy, it will take it out of the pool, because this is all a pool of EC2 instances, right? So it will take it out of service. It will not be serving the end customer request anymore. Instead, it will only be sending it to healthy nodes. Let's say out of 6 EC2 instances here, 3 are deployed in zone A and 3 are deployed in zone B, and 1 of them is down, then only 5 are in service now in this case. So when a request goes to load balancer in a round robin fashion send it to one of these 5, or you can define your own algorithm. If you don't know, a typical algorithm is, the most simplistic one is round robin, meaning first request will go to this guy, second request will go to the second, third, fourth, fifth, like that, in a round robin fashion. This is the concept of load balancing, and the end customers will only know about one component, which is your front component, load balancing component. In fact, we talked about DNS service yesterday, Amazon's Route 53. When you go to netflix.com, when you ask your DNS service, you say, can you give me the IP address of this one? You will get actually the IP address of the load balancer. You want to give the IP address of the load balancer all the time. So these guys, the end customers only know one piece here. The request will always go here. This guy, based on the logic, it will send it to healthy nodes. Any questions on that?
I have a question.
Yes.
So it seems like to me here load balancer is specific to region, but can I have load balancer across the region?
You cannot have a load balancer across the region. It's a load balancer is a region specific. So what you will do is, rather, it's a great question by the way, rather what you will do is, here is that, let's say you have 3 regions, region 1, region 2, region 3. So you have 3 load balancers in 3 different regions. All these 3 load balancers can be configured in your Route 53, in your DNS itself.
So 3 load balancer will have 3 IP address.
Exactly.
And then it's gonna eventually give me the same.
Exactly.
Okay.
And then what you can do is, if you want, you can have a geolocation based routing. Route 53, we touched on it yesterday, but there is more to it. In Route 53, there is a concept called geolocation based routing, meaning all the customers coming from France, I want them to go into Frankfurt data center. I want them to go into Frankfurt load balancer. Behind that Frankfurt data center's load balancer, there are 30 EC2 instances. All the people coming from London, I want them to go into the London region. All the people coming from Sydney, I want them to go into Sydney region. All the customers coming from Australia, I want them to go into Sydney region. Make sense? All the Asia Pacific people, I want them to go to Mumbai region. So then you are putting the load balancer there. You configure them not at the load balancer level, but one level above at the DNS level itself. When this end customer asks me, give me the IP address of it, that guy decides based on what the location is. There are multiple routing strategies. One of them is geolocation based on where the end customer is coming from. It will give the appropriate regions load balancer. That's one strategy. Or you can do something called a weighted routing policy. 90% of the people will go to this the region 1's load balancer, and 10% of the people will go to the region 2's load balancer for whatever the region. And I talked to, I think I told you guys yesterday, some strategies around this, the deployment models, like Amazon and Facebook, especially Amazon follows that, the sun's path, right? They deploy their piece of code in Japan first. Did I mention that to you yesterday?
No.
So,
No.
no?
No.
Okay. So Amazon is as you guys know, they have the code base across the globe, and right, obviously they'll have to do the deployments also, but they don't want to bring down their sites. And behind the scenes, they use a strategy called blue-green deployment. Maybe I'll talk about it, one of the days later. Essentially, maybe I'll talk at the highest level possible. Highest level, you have two pool of servers. Let's say there are, you need 10 EC2 instances, right? 10 web servers. So you have 20 servers, batch A, batch B, or pool A, pool B. So pool A will be actively serving the customers, and pool B will be sitting out there. So your new code will be deployed to pool B, and they'll be tested separately. And then at the DNS level, at the Route 53 level, you'll be switching from pool A to pool B. It's that simple. So the deployment will be, fraction of seconds. You will never be down. With this concept is called blue-green deployment. The strategy that most of the companies, it's a Netflix. Netflix brought this concept to the industry, and is that fair to say that? No, Netflix brought a lot of tools to this deployment DevOps strategy, but the blue-green deployment, actually, it was proposed in a book called Continuous Delivery. It's one of the Martin Fowler series books. He talked about this strategy. Anyways, so the point, that's aside, I just wanted to touch on that. Point number two is, the way Amazon does the deployments is that they wanted to find out every single new deployment they do it. They don't want to deploy it across all the regions all the time, across all the regions at the same time, because they want to get the feedback. They want to find out if there are any issues with the deployment. They want to find out sooner. So the way they do it is they follow sun's path. The sun's path. They start from Japan. So their newest piece of code, let's say they want to introduce some video conferencing facility, video chatting facility when you contact the customers. Yeah, I just made up this new business requirement, right? So they wanted to test it out. They wanted to release that feature. So they will release it in Japan first. They'll put it in Japan region, and they'll deploy there, and then they will get the feedback. Amazon like site, they will get the feedback within hours. They will know immediately how the new feature is working or not, if there are any defects. If it's horrible, if it's a lot of buggy code and you have issues all over, then they'll just pull out, they'll just roll back, and the rest of the world, they did not disturb it. So after that, let's say the functionality is good in Japan, it's working well, very good. Okay, next go to the Australia. I'm just making up here, sun's path, right? So then they'll deploy it in Australia region, and then followed by South America and North America, like that. So they'll just, they'll do region by region. So they want to get the feedback. That's why the concept of canary deployments is very popular now, right? You push these deployments in a smaller fashion, and then use this weighted routing policy. When you deploy your new piece of code, only deploy it to 5% of the people. Let's say Facebook has billion customers, right? What they will do is when they deploy a new feature, they will only send it to 1% of the people. So which is, I don't know, 10 million people. So they will only be sending it, the new feature will be available only to the 10% of the people, and they'll get the feedback, they'll improve on it, and then they'll slowly improve it. They'll slowly release it. They call it canary deployment. So that's a new model. So you have your blue-green deployment model, canary deployments, and all of this one strategy. Okay. So the answer to your question is, so you have your per region load balancers, and then you will maintain those load balancers, all of them, those IP addresses in at a different level, at the DNS level. Okay, at Route 53. So Route 53 has strategies for that weighted routing policy. You can say that 10% of the people will get this one, 90% of the people get this. That's a weighted routing policy. And you have a geolocation-based routing policy. You have latency-based routing policy, etc. Yeah.
And also, Venkat, so here we have the load balancer. So basically, so in this picture, we have EC2 in zone A and EC2 in zone B. So to make use of the load balancer feature, so do we have to spin up the EC2 standby instances, or will it be provisioned by AWS to facilitate the feature?
So we are mixing, we're going to a next topic called auto scaling group. In this case, okay, in a most simplistic case, if I don't have that auto scaling group, okay, I'm doing it manually. So I'll have 3 instances in availability zone A and another 3 instances in availability zone B. I'm doing it manually here.
Okay.
Okay, I'm distributing it manually. But what happens is, I'll talk about a concept called auto scaling group later. So what that guy does is, it will automatically detect the health of these issues, health of these instances. If any of them is down, then it will actually terminate this instance and then create a new instance and add it to the pool. And it will maintain the distribution across all the availability zones. It's very, very important from, as an architect perspective, to maintain the distribution, and your auto scaling group will do it. But I'll not, we'll wait on that, okay?
Sure.
So I have one question, sorry.
Yes, no worries.
So it is about the load balance taking action. So earlier you mentioned that it will identify that there are, if it identifies that a particular instance is done or failed for 2 times, then it will not send it, right? The task will not be sent to that particular instance.
The request will not be sent, yeah.
So will it send out any alert that, hey, this particular instance is down and then you need to replace it? Or
that is not load balancer's responsibility.
Okay.
That is your CloudWatch notification will do it. Okay. And again, adding to Pradyumna's question also previously, will load balancer spin up a new instance and add it to the pool? It will not do it. It will only detect it, that it's unhealthy, and it will take that unhealthy node out of service. Will it create a new EC2 instance and add it to the pool? That is someone else's job. We'll talk about that. That's something else called auto scaling group.
Okay, thanks.
Yep. So that's about load balancing, guys. So in the case of AWS, there are 3 types of load balancers. One is called application load balancer. The second one is called network load balancer. And the third one is classic load balancer. So application load balancer. Application load balancer is a load balancer at layer 7, meaning you have your network OSI layers. Layer 7 is at the application protocol level. It knows what protocol it is. It knows it's a HTTP, it's a HTTPS. If you want to, based on HTTP header. So if a specific header exists, send it to this one. If a specific header, if this particular cookie exists, send it to this target group. If this cookie does not exist, send it to a different target group. All of those logics you'll be able to put it using this application load balancer, because your application load balancer is a context aware, meaning it knows about your protocol port. Not only that, but it's actually acting at layer 7 level, meaning it knows about your HTTP headers, HTTP body, your cookies, all of that context you'll know. Okay, this is what we will be using it. And there is another kind of oh, by the way, this is only for TCP. Obviously, it's a layer 7, right? So your actually network load balancer. With the network load balancer, it acts at layer 4 level. In OSI layers, layer 4 will have information about only 2 things. What is the IP address and what is the port? It doesn't know much more than that. It can be your TCP, UDP, any of these protocols, but only at the layer 4 level. It can handle millions of transactions per second. It's at the network level. If you need that kind of requirement, if you have a need to serve millions of requests per second, and only at the layer 4 level, if you want to do something based on your cookie header, unfortunately, network load balancer is not the one. You have to go with the application load balancer. But if you want to support UDP, for example, for your gaming and IoT needs, then network load balancer is the option. Application load balancer doesn't support that. Your application load balancer will only work with HTTP and HTTPS. This guy will work with your TCP, UDP at the layer 4 level. Yeah, it only knows your IP and your port number, pretty much. That's at the network load balancer, but the high performance, it can handle millions of requests per second because it doesn't know anything about the higher than that. It only worries about the layer 4 stuff, your IP and port. Yeah, and there is a third kind of load balancer called classic load balancer. This is a legacy load balancer. You do not want to use this, but this is out there in case you have, let's say, you are already using a load balancer in your company, and that one has a session stickiness or session affinity. So session stickiness meaning your stateful. So your load balancer will detect certain criteria. Let's say there is a session ID, and then if session ID, this session ID, once I'm logged in, I want to log into only one server. Okay, this is a stateful. There's a kind of a stateless and stateful, right? With the stateful approach, what happens is once I'm logged into server 1, my request always goes to the server 1. That's a bad idea, right? You don't want to do it. You always want to use you improve your application architecture, you change it to stateless architecture. Okay, but in case you have a legacy application, you have your WebSphere, WebLogic application that goes with session stickiness, but you want to fork and lift as is, but you want to use the load balancer, then you can go for classic load balancers. Yeah, this is for your legacy applications. This supports session stickiness, but the network load balancer is at the layer 4 level. Application load balancer is at the layer 7 level. And this guy is for HTTP, HTTPS. And this guy is at the layer 4 level. There is no concept of HTTP, HTTPS really. Yeah, it's more of a TCP, UDP kind of approach, right? You can do your UDP load balancing for your gaming applications, etc. You can do that. So these are the load balancer types, and let's go and kick off a new application load balancer, and then let's add some EC2 instances to the target group. Again, when you create a load balancer, what we need to understand is there is a concept of listener here. This listener is a front door that will be listening on a certain port, in this case port 80. And then we will be creating something called target group. Target group will have all the EC2 instances across all the availability zones. And that's where you will put your EC2 instances. The beauty is you can spin up new EC2 instances, add to the target group, and your load balancer will identify, automatically start sending the request to the new ones. That is the beauty. Obviously, you want that kind of behavior, right? I need to be able to add new instances to the pool anytime, even after load balancer gets created. Make sense, guys? So let's go ahead and create an application load balancer. So how many EC2 instances we have? I have none. Well, you can create, let's define a couple of things before we talk about. This is our objective. One, we'll be creating a couple of EC2 instances. Okay. Let's do 6 EC2 instances and 2 in each availability zone. Yeah. Because we are architects, we want to make sure we distribute across multiple availability zones. So 2 per each availability zone. Yeah. So what is our definition of health? These are going to be, first of all, web servers. All these are web servers, Apache based web servers, a simple static website. You can imagine it, but it doesn't have to be static. It can be dynamic. You can spin up your Tomcat based web application, deploy your code into. So install Tomcat, create EC2 instance, install Tomcat, deploy your code, create an AMI for once you solid tested it, create an Amazon machine image and put it away. And now using the Amazon machine image, AMI, now you can create as many instances as possible. Make sense? So in this particular example case, we are using web servers, Apache, and so our ALB listener, application load balancer listener listens on port 80, obviously, because this is a web server. We understand that it's a piece of cake. And now we will create a target group. We'll create a target group. Target group is nothing but a group of web servers. It's a basket of web servers. That's all. Target group. So your application load balancer listener will take the request and forward the request to your target group. That's all it is.
Okay, one question.
Yes.
Is target group a technical term?
Yeah, it's a AWS term, really.
Okay, no problem. Thanks.
Yep. Web servers. I'll call this web servers target group, okay? And then we can add all the 6 EC2 instances into this web servers target group. So this listener will be listening on port 80 and then send it to the target group. But now, target group worries about health checks. So what is our definition of health, guys? It can be anything. Well, there's no single answer for that, but I want to keep it as simple as possible. What I want to do is, I want to create a simple HTML page called /beat. Yeah. So it's like a heartbeat. If this guy gives me HTTP status code 200, /beat.html, let's say, or heartbeat.html. Heartbeat.html. So we will be creating a new HTML page called heartbeat.html in each one of them, and this must return HTTP status code 200. 200, if it returns 200, then my instance is healthy. If it returns, obviously, 404, 500, any of the other HTTP status code, that's unhealthy. So let's talk about unhealthy threshold. After how many unsuccessful health checks should we call it unhealthy?
Let's give 2, like yesterday.
Let's give 2. Sure. We will, unhealthy threshold is 2. And then health check interval. Let's call it health check interval, meaning for each, how many seconds do you want the ALB to check for health check? Let's say 5 seconds. Yeah, if it allows. I want to be aggressive. And after how many times, let's say, application load balancer made a call to, this health check component checked an EC2 instance, it finds out unhealthy first time, right? In fact, second time also, it's it failed. It didn't give me 200. It gave me 400. After 2 instances, it marked that guy as unhealthy. But it will.
What is 200? Venkat?
Oh, 200 HTTP status code. You guys are not familiar with the HTTP status codes?
Okay. Okay.
HTTP status code 200 means success.
Oh, okay.
HTTP status code 200 means success. So if you go to any of the Amazon.com or anything, anywhere, any kind of website, let's say we go to your F12, your this guy, right? Go to network, and then what was the website we created it yesterday? nextsteptraining.com, right? Yeah, you can use even nextstep.training. You go to the home page here, nextstep.training, you will get the HTTP status code 200. Every single website. 200 means it's okay, meaning it's healthy.
Okay, thank you.
Yep. So after 2 times, we will consider as unhealthy. Even after instance becomes unhealthy, it will keep checking the health check, okay? So let's say after some time, it is healthy. But after how many times it will check each, health check interval is 5 seconds. Every 5 seconds, it will keep checking for the health of it.
Interval. Actually, there's a spelling mistake there.
Oops, interval. Thank you. 5 seconds. So but first time when it is healthy, I cannot consider as healthy. It was unhealthy for some time. And then all of a sudden it started giving me 200 status code. So 1 time, I don't want to consider healthy. 2 times, not really. I want to give 3 times. So what I'm saying is a healthy threshold. I want to put it as 3 times. Meaning I have to get HTTP status code 203 times before I consider you as healthy. Only then I will add you to the pool so that you can start serving it. Does that make sense? So it takes about 15 seconds because its interval is 5 seconds, right? So first time I called it, it returned 200. I called again after 5 seconds, 200. Again after 5 seconds, 200. Total 15. After 15 seconds, okay. So it's a third time. This guy gave me successful response. Okay, this guy is becoming healthy. It became healthy now. Let me add this guy to the pool. Did you guys understand that?
Yes.
So we defined it. Now it's a piece of cake. Let's go define it.
Okay. Now, see, since you said, so let's add that to the pool. Now, so you mean to say that after determining it to be unhealthy, let's say, it removed it from the pool.
Yep.
And then even after removal from the pool, it still continues to check its health?
Totally got it. You totally got it.
Okay.
It will continuously check because it may be a temporary blip. Who knows? It may be unhealthy for a few seconds. It doesn't mean that maybe it's draining some old resources and then it became healthy. Make sense? That's the case with any application load balancer. I mean, not just nothing to do with AWS. Guys, all these concepts have got nothing to do with AWS. That's the beauty. So you are learning not only AWS, not only cloud computing, you're learning load balancing principles, general architectural ideas. Okay? You guys are becoming architects. That's the idea. Okay. Go to services here. Search for ALB or actually EC2 only, because load balancing is part of EC2 at the high level. So go here, see this one, load balancers, click on load balancers. I do not have any load balancers at this point. I'm just thinking here. because we don't have any EC2 instances, can we go ahead and first create an EC2 instances and then come here? I think let's do that. Let's do that. So this is my plan. This is the game plan. Create EC2 instance from scratch, and then create an AMI. Because after creating an EC2 instance, number 2 is create heartbeat.html for all of them. Create heartbeat.html and index.html. Index.html, and then create an AMI. So from Amazon machine image, then we will create other EC2 instances from AMI. Then create then we will create ALB. Yeah, let's do that.
Okay, one question. See, you have an AMI already. Now, are you incurring any expense for keeping that AMI alive?
Yeah, because where is your AMI? Because we have one AMI, yes. Because what happens, AMI, the associated, the EBS volumes, you will get the snapshots. Take a look at the snapshots. See that?
Yeah. So there is an expense for keeping the AMI?
Not for AMI, but the AMI
will
have indirectly the snapshots. So you are keeping the 8 gig snapshot here, right? So you will be charged for this one. Does it make sense?
Okay.
Once I deregister that, my snapshot will be gone. You can say.
Okay. Now, is there any way of checking the specs of an AMI? Like, suppose you have not only 8 gigs, but suppose you have, let's say, five ESB drives. You've taken a snapshot of a EC2 instance that had 5 ESB drives.
Mm-hmm.
Now, would you be able to go and check all those specifications of the AMI?
I didn't understand. Okay. Actually, can you hold your question?
Yeah, sure.
For later? Yeah, let's execute this one. Please take a note of that and we'll get back to that. Okay, because we are switching a topic a bit. So let's go ahead and create an instance. Linux AMI, Amazon Linux AMI. Okay. And I need my Unix commands. So this is what I'm going to do. So this is what I'm going to do, right? So let's write the simple script. So what I'm planning on doing is echo h1, I'm server 1. Yeah. Or I'll say hello from server 1. Yeah. So I'm sending this guy to var html index.html. And then what I will do is I'm going to echo. I'm going to say I'm healthy to var html. What's that HTML called? heartbeat.html. Did I get that right, guys? So this is how my AMI, this is how my EC2 instance is going to look like. Okay, this is my EC2 instance and this is my code. Well, my subnet, let's create this guy in 2A, auto assign public IP. This is good. Add storage.
Heartbeat script.
Yes.
Put the
yes.
tags.
Go ahead, one at a time. Kasi, go ahead.
Yeah, there is a number of instances when we create EMA, this
actually,
EC2, right?
You are right. You are right. Actually, we can do that. We can absolutely do that. 6.
Okay. It will be created.
But all of them will be created in a. All of them will be
Same zone, right? Like same
No,
availability
same
zone.
zone.
So probably
Actually, let's say no preference. Let's say no preference. Then
that would be easier. I was
Okay,
thinking,
before you shoot, one question is there.
yes.
That is in the echo to the heartbeat.html. You have not put the h1 tags or anything, any tags.
I did. It doesn't matter because as long as I get a text back, because I'm not looking for text. In my healthy scenario, I'm only looking for HTTP status code 200. It doesn't matter. I don't look at what the content is. Understand that? When I make a heartbeat.html call, I will get this one. I'm healthy, but I don't care about the content. I'm looking at give me the status code. Did you understand that?
Yeah.
Okay. So I know web server 1. Let's go. That's a good call. Let's see how it distributes. Okay. It's doing all of them in 2B. Okay. That's okay for now. I know we put all of these eggs in one basket, but that's okay. Just for the time being, because once we talk about auto scaling group, we will find out more. Yeah, we'll talk. But this is a bad idea, right? You're putting all 6 into one availability zone. That's a bad idea. So we created 6 EC2 instances. So what we'll do is we'll change. Let's go ahead and change each one of the content. So this guy, let's make sure. Actually, let's make sure it's public IP is running. Where Apache is running? Nope, not yet. So
Looks like it's still initializing.
It's initializing.
Let me go ahead and connect to this guy as root. Nope. Nope, it's not there yet. So you always have to make sure that there are no problems with your script. Yep, I don't think so.
one quick question.
Sure.
If when you are starting any,
sorry. So it's up. Looks like all of them should be up. So what we'll do is we'll change each one of them. Okay. And 1 second. So /heartbeat.html. I'm healthy. Good job. And then if you look at index.html, you'll get that. And I don't need to give the index.html. I can just give this one because index.html will be acting as your index document, meaning when you don't have anything, that's your home page. This is your web server 1. So what I'll do is I'll just quickly, we can go ahead and ask as I type, no problem. Manohar, you can go ahead and ask, no big deal.
okay, thank you. So my question is like, when we are starting an instance, what could be the time like we should wait for whether to know if it is successful or not? Or is there any possibility for the failure of any particular instance being taken or is being created?
Instance being this is number 3. Yeah. This is number 4. Oops. Number 5, I know we didn't touch number 4, number 5, and number 6, right? So maybe I should have taken with just 2 instances. And I should have given you homework to do. Okay. Now, so when you start the instance, what's the possibility of going it down or something? Not being successful? Is that the question?
Yeah.
Well, your script is most likely your script is wrong, and then somewhere after a couple of statements it doesn't get executed. That's the most likely scenario. Okay, that's the most likely scenario. So, and you can automate all of this one, you know, using some cloud formation templates and all. And just
but if
because
there is a program error, then that will be error. That error will be there for all the instances, right?
Yeah, of course. Okay, this is web servers. Yeah, you're right. So I'm checking the health of individual instances, guys. So it looks like all of them are good. So individually, I'm checking whether all these guys are really, really good, right? Healthy. Yep, looks like all of them are good. So now, okay. So 1 to 6, we have 6 EC2 instances. Unfortunately, they all happen to be in the same availability zone. We put all the eggs in one basket. That's a bad idea, but it's totally fine for now. For now, we'll be talking about auto scaling group, the concept of auto scaling group, and then it will automatically distribute it. In fact, it does the work for us. Okay. So what we'll do is, currently I don't have any AMIs. For a different reason, I want to keep one guy. I want to create an image. Okay, I want to create an image.
So once you have used the AMI, it goes away?
Nope, I deleted it.
Oh, you did. Okay, thanks.
Yep, I'll say that my web server AMI, So this is my web server AMI, and keep this. I'm creating. Yep, I created the image. So I kept my image separately for a different reason. I'll talk about that reason. Okay. So these are my 6 EC2 instances. All good. Everyone is healthy. Now let's go ahead and create an application load balancer. So if I want to, so we created a website yesterday, nextsteptraining.com. We bought the domain and configured Route 53, right? So now, before we go to application load balancer, since we talked about Route 53 yesterday, just wanted to show you guys something. So now we didn't make any changes to Route 53. Your DNS is still giving the old IP address. Okay. This is still giving you the old IP. Your A record is still pointing to this 3.15.227.188. That means your nextsteptraining.com should not work and will not work, because when my computer asked, hey, give me the IP address for this particular website, well, by traversing all through the top level domain name and your root DNS, actually first it goes to my ISP, internet service provider, then it goes to root domain resolver, and then it goes to top level domain resolver, and followed by it goes to Route 53, and Route 53 gave me this IP address, and this IP address has got nothing. It's not even my IP address now, right? And that IP address is not available anymore. So my web server is not running on this one. So because this IP address doesn't exist, or sorry, that's a wrong way to put it. Because my web server is not running on this IP address, my site is down. So now if I want to bring up my site, what I want to do is, so if, let's say, imagine there is no application load balancer in the picture. So then I have to give probably one of the web server's IP address. This is the public IP. And then I'll go to my Route 53 and then change my A record. Okay. So that's the best I can do. I can do more than that. So select this A record and then actions, edit, and change this guy. Save changes, and now go to www.nextsteptraining.com. You just have to wait for the DNS propagation to happen. We can do a DNS propagation like how we did yesterday. Let's see. 18.188. Yep, it's getting propagated. Every time you change your DNS, your caching come into picture. It's cached. So let's come back after 1 minute or so. Let's keep this guy. Okay, so let's come back. I wanted to show you that if at all your load balancer is not there, this is my A record. Let's make sure that this IP is working fine. Very good. This is good. So that means it will come up in just, yep, it came up now. You all can test it. So you guys all can test this website like how you did yesterday. So essentially your website is pointing to just one EC2 instance. Yeah. So the point is, if I go to that EC2 instance and bring down Apache, what happens? If I go to that website and bring down Apache on that, if I stop Apache on that one single web server, what happens? Then my site will be down. My site will be down, right? My site will be down. I do not want that to happen. That is why I'm going to create my application load balancer. So let's go ahead and create an application load balancer. So go to EC2 and click on the load balancers. So finally, after all of this, now I'm back to my load balancers. So we precisely know what we want to do it because we went with the design first approach. So we have clearly designed what we wanted. So let's go to create load balancer. So this is what it is. Your application load balancer, network load balancer, and classic load balancer. Well, application load balancer will deals with HTTP and HTTPS at the layer 7 level. And you will be able to control the traffic based on your HTTP headers, cookies, cookie settings and all. But with the network load balancer, it happens at layer 4 level. It deals with TCP, TLS, UDP. Okay, this is it for the network load balancer. Okay, but your TLS offloading, SSL offloading happens at network load balancer also. And another one, guys, very important for the exam, application load balancer by default will not give you a static IP. It will not give you an IP address for your application load balancer, but your network load balancer will give you that. There are some strategies to get around it, but understand that for now. And the classic load balancer, it's a previous generation. You don't want to use it, but if you have within your organization, if you have a load balancer that does some session cookie, session stickiness and all, you can use your classic load balancer. Yeah. So let's go ahead and create an application load balancer. Click on that. Now I'm going to call it this application load balancer. What is it for? Next step training, right? Next step training, web servers. Yeah. Next step training, web servers load balance. So this, guys, this load balancer's responsibility is to balance the load across all the EC2 instances for this next step training website. Is it an internet facing? Yes, it is an internet facing IP address type. Do you need both IPv4, dual stack IPv4 and IPv6? No, IPv4 is enough for me. And then, as I told you, every load balancer has a concept of listener here. So what port are you listening on, load balancer? Well, I'm listening on port 80. Okay, ideally you want to change this to port 443. Well, you know, once you have your own SSL certificate, you want to change this to 443, but here port 80. Now, okay, application load balancer will be created, but where do you want this load balancer to send the traffic to? How many availability zones do you want this application load balancer to send the request to? Please send it to all the availability zones. Send my request to 2A, 2B, and 2C. Ideally, all the, you know, as many availability zones as possible. But if there are some restrictions why you don't, if there are some good reasons why you don't want to, you know, send it to certain availability zones, then you can unselect it. In our case, practically, we don't need 2A and 2C. You know why? Because we put all the eggs in one basket. But go ahead and put this, select it anyway. So essentially, it will send to the targets across all the availability zones. Of course, all of our 6 targets within this one availability zone, but we designed it wrong. Ideally, we want to do it in, you know, 2 here, 2 here, 2 here. Make sense, guys? Okay. This add-on services, don't worry for now. The statement that I made just now, application load balancers will not give you a static IP. They will give you only the DNS name, a long DNS name. That DNS name, you are going to configure it in your Route 53 so that your website request will go to your load balancer. It will not give you a static IP. If you want a static IP, if there are some good reasons, let's say you want to create an application load balancer, okay, and you want a single IP address for that. Why do you need a single IP address? Maybe you want to share this IP address with a vendor, and that vendor has a IP whitelisting. They do not allow traffic to any IP address, only to the whitelisted IP address. If they need to whitelist certain IP address only, in that case, you need to use this concept of AWS Global Accelerator. Maybe we'll talk about this, you know, some other time. But if you select this one, then you'll get a static IP for your application load balancer, and then you can take that static IP and put it into your Route 53. But if you do not have it, how do we do it? I will show you. This is an add-on service. Yeah, it's a relatively new concept also, the AWS Global Accelerator, and typically they're asking in the exams nowadays, especially in this new certification. Configure security settings. The next one is so it's asking improve your load balancer security. You opened up the port 80. You know, go for 443 is what they're saying, but we know what we're doing. So go to next, configure security group. So it's asking what security group do you want to allow for my application load balancer? What ports do you want to be open? Well, HTTP, yes, port 80. So I'm using this web server security group. This web server security group will be port 80 will be open to the world. But if you have any restrictions, create a new security group and attach that security group to your load balancer. Like how you are attaching a security group to your EC2 instance, you can attach a security group to your load balancer also. It's that simple. Configure routing. Now, we created this. Let's go back to this diagram here. So we created this load balancer, and we have the 6 EC2 instances. 6 EC2 instances together, we are going to create a target group here. We're going to create a target group there. So I'm going to create this target group here. So this will be Oh, sorry, you understand what I'm saying here. So I'm going to create a target group. That group will have all the individual targets. Individual EC2 instance is a target. Make sense? That's what I want to do it now. So what do we call this target group as? I will call this as web servers.
Didn't we give a name for that target group before?
We gave a name for application load balancer. They are logically different. Application load balancer, one logical entity. This guy will forward it to the target group, and target group is responsible for health checks. Load balancer will be listening on a particular port, and then when a request comes, load balancer will give it to the target group, and target group is responsible for health checks, and it knows which node is healthy. So essentially target group gives it to the appropriate target, only the healthy nodes. Does that make sense?
Yeah, but we created one target group before.
We created a load balancer.
Oh,
see here in the step one, we gave a name to the load balancer. Yeah.
Okay.
So next step training website, web servers for next step training website. I believe it might accept hyphens. So this is probably more readable. Next step training website. Okay. Target type. So are these, what are these targets? Are these EC2 instances? Are these IP addresses? Are these Lambda functions? These are EC2 instances. So it's an instance type. So now guys, earlier we created a listener here. This listener is to take the request from end consumers. But now after taking the request, it is going to forward to the target group. Okay, target group is listening on the target group will have individual targets. So individual targets, are they listening on port 80? In our case, the individual targets are listening on port 80, right? Because we have the HTTP web server and all of them. But let's say I'm listening, my load balancer is listening on port 80, but I have a bunch of Tomcat instances here. Then I will keep my Tomcat port is 8080, the default port. And I will put port 8080 here. Does that make sense? Did you understand the difference between your load balancer listening port versus your target listening port?
Yes.
Your load balancer is a front door that's listening on a particular port, but your target listening port does not have to be the same as your load balancer listening port. Understand that point? Make sense?
Can we have more than one target group?
Can we say that again?
Can we have more than one target group?
Can we have a more than one target group? I don't think so, Kiran. Let's find that out. Okay, let's answer that.
It's okay. Thank you.
Let's put this one. Okay, so I'm just thinking, keep thinking. So protocol is 80, and now this target group is responsible for health checks, right? So now this is the definition of your health check. Okay, what is the definition? Your HTTP protocol, sure. So what is our definition of health check? / heartbeat.html. This is what we defined, right? Remember? We designed first and then go to advanced health check. Okay, let's talk about it. Port, traffic port. What port do you want to use it? Yes, traffic port, which is port 80. Yes. If there is a separate port for heartbeat health checks, you can override that and you can give a different port. But for us, your heartbeat.html is also on the same port as target port. Healthy threshold. After how many times you get the successful response, do you want to consider an instance as healthy? I think we said 3. Yep. And then unhealthy threshold, we gave 2. And timeout is
5 seconds.
When load balancer tries to contact an instance, your target group tries to check for /heartbeat.html. It is checking for health check, After how many seconds do you want to consider that as timeout? 5 seconds. I want to call this as 2 seconds. After, if I don't get the response within 2 seconds for slash heartbeat.html, then I want to consider unhealthy. Okay. And the interval, and how frequently do we want to do the health checks? I believe we gave 5 seconds here.
Oh, yeah.
And then success codes. What HTTP success code do you want to consider as success? 200. Or you can even give the range. All the 200 series, 200 to 299, you can say it is success. You can even give the range. But in our case, let's go with the 200 itself. But you can definitely give the range. Okay. Next is, this is your target groups, register targets. Now we created a target group.
So Venkat, what is that override there? There is traffic port and override, right?
Right. So this is all related to health checks, Madhavi.
Okay.
So if your health check slash heartbeat.html, this is your heartbeat, right? If it is, if your health check is different, if it is using a different port than your incoming traffic. See, your web server is listening on port 80. Every single request will be served on port 80. But just for health checks, if it is listening on a different port, you can override that.
Okay.
Let's say my health check itself is doing on HTTP, on 81. Then it will do a HTTP colon my host name, HTTP colon / my host name colon 81 / heartbeat.html. That's what it does. Otherwise, it will use the default traffic port. Make sense?
Yeah.
Wonderful. So target group name cannot be longer than 32 characters. Okay. So let's try that. Well, a target group has been created. So target group is nothing but a logical entity that will hold all the targets. Yeah. So these are all the targets we have it. Now 1, 2, 3, 4, 5, 6. In fact, these are all available, but currently this target group does not have any registered targets. So let's go add all 5 of them. Or web server 1, let me do an odd number, right? 1, 3, 5. Let me add three EC2 instances to the pool.
Okay, one question at this point.
Yes.
That is, see, you created a target, but over here in the bottom, I see a bunch of web servers.
Mm-hmm.
How did it pick up those names?
Oh, we gave those names, right? EC2 instances.
Oh,
yeah.
Oh.
Go to your EC2 dashboard, you will see that. I gave those names.
Okay, you gave those.
I gave those. Yep. So out of the 6 web servers, I added only 3 of them to the pool, to the load balancer pool, and then click next review. I did not add the remaining 3. We will add slowly as we test it.
So does this mean it's gonna only go to those 3 web servers?
You precisely got it. So my load balancer, even though I have 6 EC2 instances, my load balancer is configured to go. My load balancer's target group has only 3 targets, 3 registered targets. So under load balancer, there is a target groups here. This is my target group. Okay. And go to targets. So these are my 3 targets, and it is in initial state. See here, it is in initial state. Keep refreshing. After 15 seconds, we should see healthy, because it takes 3 times 5 seconds, because it's going to run. Interval is 5 seconds, and it takes 3 times to become healthy, because our healthy threshold is 3. So it keeps checking in the behind the scenes. Let's keep waiting. Group details, unhealthy threshold 2. Okay, let's keep going. So meanwhile, let's go back to our load EC2, load balancers. while our load balancer is warming up. Oh, it's load balancer itself is it's still provisioning. It takes time. So guys, once we have the load balancer here, right? Take a look at the DNS name. See this one? This is the DNS name. It did not give you a static IP address, a public IP address. It did not give you an IP. And then you cannot assign an elastic IP. I know I have not used this term before. There is a concept of elastic IP address. Elastic IP is nothing but a static IP address. I'll talk about this right after this, right after the load balancer. But you cannot assign an elastic IP to your load balancer. Understand that going into the exam also. It is active now. So this is this whole DNS name. You can copy this guy, copy and use the whole DNS name to go to your load balancer. This is my first request went to server 3. My second request went to server 5. 35135135135. You see that? My first request, this request went to 3. It went to load balancer. Load balancer sent it to a web server 3. It went to web server 1, web server 5, 3, 1, 5, and go to your target groups here, and it must show that all of them are healthy. Let's go to targets. These are all healthy now, because after 3 consecutive health checks are passed, node becomes healthy. Does that make sense?
Venkat, like we are saying web server 135 for now, but if it's my ideal website, I would show the same thing to all of the web server, right?
You got it. Because ideally your website, great question. So if you go to Amazon.com, right? Yeah, whether my request went to server 1 or server 100, I should get the same response, right? So in this case, just wanted to prove you that we put different code in each one of them. But ideally the code will be same. Right?
Yes, so one question here. So let's say I don't put the font, like I'm gonna see the Amazon website, any server I go, but is there any way to check which traffic going to which server?
And only on the server side they do that.
Okay.
Not on the client side. Okay. So that's it, guys. So these 3 are becoming the target group. So let's go back to the target group and let's create a new target group and then see. Let's try adding 2 target groups. So here, instances, a target group consists of instances, sure. And target group name is, I'll call this as next step website, next step web servers. I'll call this as even number web servers, right? 135, 246, we still left it. Port 80, VPC, health checks / what's that called? Heartbeat.html. Let's create a new target group, and then advanced health checks, traffic port, same. Yep, healthy threshold is 3 times, right? If I'm not wrong. Yeah, and unhealthy is 2. Timeout is 2 seconds. Interval is, of course, I can define my own. Interval is 5 seconds. Yeah, and success codes is 200. Let's go ahead and create timeout 2 seconds. Sorry. Very good. So it is asking me to pick the appropriate targets. So I'll pick 2, 4, 6, and then available instances. So, okay, I wanted to create target. Oh, sorry.
So the
Include
same
reports
instance
for
can
the
exist
dedicated.
in multiple targets?
What's that? Yeah. Same instance can exist in multiple targets, yes. So this is my even. I can change this guy to I can change this guy just for fun to odd. Now let's go to even, go to targets. It's unused. Target group is not configured to receive traffic from the load balancer. Very good. So we have a target group, right? So this guy. Now let's go to load balancers and then let's go to load balancer, edit subnet, security groups, attributes. No. Oh. Let's go to target groups. Group details. I wanted to attach this guy to my load balancer. It is my target groups. Actually, the load balancer is this one, right? Okay. So this is a load balancer. Okay. So let's go check this guy and then I created. It's not attached to the load balancer. Now I'm trying to attach this guy to the load balancer, right? After creating it.
Register targets?
Nope, it's you are registering the targets because your target group is your logical group of registered targets, right? So now you will associate this guy.
But this has been already associated with another target group, right?
No, we are talking about the target group. We are not talking about the load balancer here. So how do I attach my target group to the load balancer? I want to tell, so create a target group, okay, instances, target group name, VPC, health checks, advanced health checks, tags, optional, and register.
We need to create a load balancer then.
We created the load balancer already. So load balancer.
But that is already attached, right? Attached to a different target group, right?
So, yeah. So we are trying to figure out if, so I'll call this as a load balancer 2, right? LB2. Internet facing. This stem from Kiran's question. IPv4, HTTP, availability zones, sure, BC. I don't need global accelerator, security settings, sure. Security groups, sure. Web servers. Let's see. Okay, target group here. Rather than creating an existing, I can choose an existing target group, my even. Oh, so see this one here. I think I answered wrong earlier. See this one here. So this guy is not available because this guy, this target group is he's already been assigned to a load balancer. So it's a 1-to-1. So yeah, we learned it hard way. That's good. So yeah, all of this because my existing target group is there. Register targets. Okay. So this is the only way. I can go ahead and create a load balancer, but I'll not. But I answered your question in a hard way, and I learned myself something new. That's a good thing. Beautiful. You guys got it? Now let's go back to the target group. What I want to do is I'll delete this target group. I'll tell you why. Now I will add new targets. So currently we have added 135. Now let's go ahead and register more targets. My 4, is it 246? Yeah, 246 are not added. Very good. Now see 3 of them are healthy and 3 are initial states. So this is my DNS name of application load balancer. Yeah, it's still going to 135. But it started sending traffic to number 6, 246. Did you see that? 1, 5, 2, 4, 6, 3, 1. You see that? It's going to all 6 servers now. One in a randomized order. It doesn't know the numbers, right? So now all 6 are healthy, guys. So now let's do the last linking part. So we have an application load balancer. Now, what's the last thing I want to do?
Route 53.
Route 53, exactly. Now let's go back to Route 53 and then give our website. What's our website? nextsteptraining.com. Oh, not .net, not .com. It's going to only server one. You call it 100 times, that's where it goes, right? So first, let's go to load balancer and then get the load balancer DNS name and update our A record. Route 53. So this is, did you guys understand why I forced you to spend $12 yesterday and register the domain? I want you to get the experience actions, edit, and then here, IP address, see this one, alias to another record in this hosted zone. Oh, no, alias to load balancer. See this one, alias to application and classic load balancer. And then Ohio region. And then, yep. So it automatically gave this next step training web servers, you know, and then that's it, save changes. Now let's take a look at our A record now. See this one, A record is, this is our DNS name of application load balancer. So let's wait for, now let's go to DNS propagation and see what happens, okay? Let's go to DNS propagation. This is the old stuff. So let's go and refresh it. So 18.216. Did you see this one, guys? It is giving you more than one IP address now. 18.216.18.235, 18.233.72.45. It is giving multiple because it is a load balancer. And load balancer, by the way, come back tomorrow, the IP address could be changed because that is why it doesn't give you a static IP. IP addresses could be changed for these load balancers anytime. That's why you don't want to use the IP address. You rather want to use your DNS name. So we applied the DNS name to your Route 53. Now we can try going to the nextsteptraining.com. There you go. It already started business. You can keep checking your web. I think I sent you the website. Keep checking. This is my website now. It's going to all servers.
Why is it going to multiple servers, Venkat? So ideally, it needs to go to one server, and then if it goes down, then it needs to switch to second one, right?
Nope. The reason we have 6 targets there in the target group, and load balancer is configured to send traffic to target group.
Oh, okay.
Okay, this is exactly how it should behave. Because we have 6. In case something goes down, then what happens? It will not go to that particular server. So I will show you that. So let's watch that. Go to EC2 running instance. So what we will do is, let's take out the number 1. What we'll do is number 1, connect. I can do a hard stop on that, but rather I will stop I will stop Apache server. It's simple. Stop service HTTPD, right? I believe. Nope. Service stop HTTPD. Service stop HTTPD. The service command supports only the basic LSB action. Service HTTPD stop. I was like crazy. So my HTTPD is stopped. Yep. My Apache is stopped. So now let's go to target groups first. Let's go to target groups first. By the way, this is what I'm saying here. Look at my EC2 here in the web server 1 is running. It's healthy. When it comes to my virtual machine, it is all healthy, beautiful. But inside that, Apache is down. Okay. So that is why it's very important to look at our own definition of health checks. Go to target groups, and then take a look at your targets. Out of 6, 5 of them are healthy. The 6th guy is unhealthy. Make sense? Now you can go check. You will never see web server 1 because your load balancer already realized that number 1, web server 1 is unhealthy. It has taken it out of service. Make sense? Now the magic is, go ahead. The magic is, let's bring HTTP, let's bring back HTTPD, and then you will see after 15 seconds that it is healthy. Go ahead. Is that Satish?
Yeah.
Go ahead.
The load balance DNS has DNS name, right? How it is become public that when you give that load balancer DNS name instead of nextsteptraining.com, but it is serving you the request right earlier.
Absolutely. So what Satish question is, go to EC2 dashboard, if I understand that right. Load balancers, go to load balancers. This is the public DNS name. See this one? This is the public DNS name. To take a look at this one, AmazonAWS.com. And before that, elb.amazonaws.com. Before that, useast2.elb.amazon.ast. And then next step training web servers dash some randomized number dash dot region dot elb.amazonaws.com. Does it make sense? This is your public DNS name. Amazon maintains that. So it goes to your elb.amazonaws.com and it maintains this mapping and it appropriate IP address at that time. Does that make sense? So when I go to this one, what would now, if I hit enter now, what happens? My browser looks for, okay, I need the IP address of this guy. Okay, it asks somebody, it asks my ISP, internet service provider guy. That guy will go to the root one. He will say, oops, it's a .com, right? Okay, I'll give you the top level domain. All the .coms will be answered by this guy. Okay, it will go there. And that guy will say that, okay, you're talking about, I don't know exactly the IP address of this one, but I know that elb.amazonaws.com, okay, that's registered with me as this route 53. This is not our website, Satish. This is Amazon's own website. It goes to Amazon's own Route 53, and that guy dynamically will give you an IP address for our load balancer. Does that make sense?
Yes.
Go ahead. Think through it. And I want you to know this is no magic with ALB. Let's go to EC2 for a second. Let's go to running instances. Go to our web server 2. Take a look at this one. Web server 2 has a public IP, right? And similarly, take a look at this. There is a public DNS just for the web server 2. See this one, EC2 dash this IP address dot useast2.compute.amazonaws.com. This is a public DNS too. This is a public DNS too.
Okay.
So if we try to access the public DNS of web server 1, now it will not be accessible, I think, right? HTTP.
You got it. We can try doing that. So either go through the public IP or even go to the public DNS. So this is not our website's Route 53. I want you to understand that because this is not ours. This is AmazonAWS.com. This is compute.AmazonAWS.com. Does it make sense? They are maintaining it. They are making it dynamic. Does it make sense? Like your Facebook.com, right? Like your Facebook.com is a website. They give subdomains, right? Venkat.facebook.com. venkathari.facebook.com. If I go there, right? How are they able to do it? That's not our website. It's a Facebook's one. They are dynamically giving an IP for that. Does that make sense?
Yeah, but actually the registered actual registration with the DNS is that's I wanted. So it makes a call uh, to these servers, and then it will find out with the public DNS something. Yeah, I think I got it.
No. Can you repeat? I don't know. I don't think I got it. But let's. Can you repeat
No,
the
this is
last statement? You're breaking a bit.
no. I'm trying to say is like this is nothing to do with our actual domain.
You got it.
Uh,
That is nothing to do with our domain because this is not the domain that we own it, Satish. See this one?
Yeah,
This is
right.
AmazonAWS.com. This is like
Yeah.
your satish.facebook.com. It's very similar to that. Who owns the facebook.com? Those domains, they will give you the IP. Probably, and 9 out of 10 times, it's probably your own, facebook.com itself. And by taking that subdomain, your Satish dot, they know how to redirect to your own dynamic page. They make you look like you got a brand new site, but it's part of a single dynamic page, right? It's a separate servlet in your Java world.
Yeah.
Does it make sense?
Yeah, makes.
So basically, we are saying that there are multiple IPs for the same domain, right? One provided by Amazon, one that you have created.
So what we are saying is there is a public DNS for each one of these EC2 instances, that there are multiple front doors. Everybody's door is open. If you say that, everybody, if you somehow get access to this public DNS name or public IP, you'll be able to go to that specific server. There is no reason why you want to do that, but you can go if you want to. Okay, keep that point aside. Now, similarly, what we are saying is our load balancer also, they gave a public DNS here. If you do not have your own Route 53, your own domain name, use this. Send it to all of your friends. If this is your website, you can happily send it. It's the same case with all of your people, right? Let's say there is a website called wix.com, for the websites, right? You guys know about this. This is a website builder. So here, once you sign up, let's say venkat.wix.com. That is my own website. Does that make sense? This is a dynamic one, but they own it, wix.com. They gave you a subdomain. That's all it is. It's a dynamic one. So similarly, we have a DNS name for our application load balancer. So if you don't want to create a separate website, you can happily give this one to anyone. Okay, this one will not change. You can happily give this one. But I created my own website, and then I added a record to my website to this one, so that now I can use nextsteptraining.com rather than using this convoluted name, long name. Does that make sense? Absolutely, to everyone. Okay. So, by the way, since I brought this point here, there are 6 EC2 instances here, and each one of them has a public IP and public DNS name. Ideally, we do not want that. This is not a good practice, because you're opening up the doors to every single, it's like your house is having 6 different doors. So you can come from anywhere. Nope. We want everyone to come through the front door. That is our load balancer. So ideally, we should close all of this one, meaning we do not want a public DNS. We do not want a public IP. So where can I configure that? When you create a new instance, I can show you here. See this one? Auto assign public IP. You just say disable. I do not want public IP, because I do not want anyone to come to this instance bypassing my load balancer. I want every single one of them to come through the front door. That is my load balancer. disable that, then nobody can come in except your load balancer. Your load balancer will be able to forward the request, and you have only front door to your house. And that's exactly how you want to architect it. Does that make sense?
We cannot disable it after we created the web server, right?
Can we disable the public IP action? There is an instance settings here, and there is a auto attached to termination protection. There is a instance settings. Let me check. Networking. I don't. Oh, manage IP addresses. Nope. Nope. Looks like you can't. Yeah.
If we want to change anything, always we have to go through the console and we have to modify, or any other ways we can.
Oh, that's a great question. That's a great question, actually. So no, the beauty, if you are doing everything through console, okay, then my day one, whatever I talked about, cloud computing and Amazon exposes as an API, you can infrastructure as a code does not make sense. If I'm a human going through this one, nope, all of these ones are exposed as an API. You can call API. You can call, Amazon gave you a tool called CLI, command line interface. You can use command line interface to do all of this one. Okay, we'll be talking about it when we talk about S3, but the command line interface is only one way to interact it. Console is another way to interact it. But the most interesting way to interact with is through API itself. They exposed all of this one through REST API.
Okay, thanks.
Yep. So they exposed all of this one. You can create a new instance using REST API. You can create application load balancer using API. That is the beauty. You can write a piece of code and then provision the entire infrastructure of your company within 30 minutes. Yeah. I'm not kidding. You can do that. We did it. Does that make sense? Okay. So target groups, we have how many? One of them is unhealthy, right? Number one. So I just wanted to, we can completely wrap this up with one last item. It's a no-brainer, but I wanted to show you anyway, which is HTTPD service start HTTPD. Once my, come on, service HTTPD start. So I'm just starting my Apache. Yep, my Apache is up. I can even make sure it's going good through my IP. Now you can go to your target group after what, 15 seconds? Remember we were talking about it. It's unhealthy. Even though it is unhealthy, it will keep checking the health check of it. It came back automatically. Somehow it was unhealthy for some time, and then it brought back. Again, it is healthy now. It's active now. It is actively serving the traffic. You can go check. You can go check to your website now. It should be going to your number one also. There you go. The number one, I saw it somewhere. Yep, there you go. There you go. That's about load balancing. That's about application load balancing. Yeah. Fun stuff.
One quick question.
Absolutely.
So did we create two load balancers or one single load balancer?
We created one single load balancer.
And that was assigned with all the 6.
Exactly. So load balancer is a front gate that will be listening on a certain port, and then it will forward the request to a target group. Target group is nothing but a logical entity that will hold all the targets. And the target group is where you will configure the health settings, health checks. Okay, what's your definition of health of that EC2 instance? Okay. Any questions?
And we have only one, sorry, only one.
Go
So we
ahead.
have only one like target group here. We don't have two target groups that
No.
are assigned to single
We
load
realized we
balancer.
cannot do it, right? Hardware. That was one question. Does it make sense?
Yes.
Venkat, can we
Yes.
have more than 1 year record for the Route 53?
You can.
Okay.
You can. So there is in Route 53, you have these routing policies. Simple routing policy, geolocation based routing policy. There is a multi-valued answer based routing policy. In that case, you can set up that. So it will randomly give you one of the IP addresses. Okay. So poor man's load balancing, if you don't want to do a load balancing, it's a bad way of doing it, but I'll answer it in a crazy way. So rather than creating a load balancer, you have 6, right? You can configure your Route 53 and have 6 A records, multi-valued A record. Okay. So what happens is when 6 people ask, okay, hey, what's the IP address of this guy, this website, nextsteptraining.com? You all get 6 different IP addresses in the Route 53. You are, rather than configuring your load balancer, you configure directly your EC2 instances. Does it make sense? But it's a lousy way. The reason it's is all the other health check benefits and all. I mean, Route 53 can do health checks, especially the multi-value to an extent, but it's a very, very poor. DNS is not meant for that. DNS will give you an IP address. And
Why I ask that question is, as we cannot attach 2 groups to the load balancer, I mean, as we can assign more than one A record, that means you can have multiple load balancers, right?
Absolutely. Oh, absolutely. Absolutely.
Yeah.
And that was the answer for Pradyumna's question earlier, right? So I have like a 5 load balancers across 5 regions. How can I do that? Route 53 is not region specific service, guys. Route 53 is a global service. I want you to know that. Okay. So you have 5 load balancers across 5 regions, and you can put, you can configure your DNS settings in Route 53 to distribute the load across all 5 load balancers. So essentially Route 53 will answer one question: what is the IP address of my website? So a guy asking that question from France will get one answer. A guy asking from Sydney will get another answer. A guy asking from Michigan will get a different answer. That's all it is. Yes. But your answer is that simple. What is the IP address of my website? There's nothing more than that.
Thanks.
Yep. Fantastic. So that's about load balancing, guys. And I have a nice homework set up for that. So I was hoping to kind of do an auto scaling group also, but not fair to do that. It's a decent concept by itself. So let me go ahead and stop the recording here.